Hello everyone, welcome back. In this presentation, we are going to focus on another interesting thing about ER diagrams, the extended ER features. We have already seen about the basic components of ER diagrams. We have also created 3 ER diagrams for understanding the logical structure of ER diagram. In this presentation, we are going to exclusively focus on the various extended ER features. At first, let's see what are all the topics that we are going to cover in this presentation. At first, let's start with recapturing the basic structure and components in the ER model. Then we will understand what is extended ER features. After understanding the need for extended ER features, we will start focusing on the specialization feature in ER model, the generalization feature in ER model, aggregation in ER model, inheritance in ER model, and finally, we will see more design options. Let's start with the recapture over the basic structure and components in ER model. When we talk about ER diagrams gives the logical or the overall structure of the database design. ER diagrams play a vital role in the ER model because in ER diagram, everything is represented graphically. So many symbols are used. So ER diagram, entities and relationships are important. Talking about entities, we have 2 types of entities or entity sets, the strong entity set and the weak entity set, where strong entity set is represented with a rectangle, a weak entity set is represented with a double rectangle or an outlined rectangle or divided rectangle. Remember, undivided rectangle, we call it as a strong entity. When we have a divided rectangle or double rectangle or outlined rectangle, then it is a weak entity set. This is about entity. Talking about the relationship, obviously we will have 2 types of relationship. One is a strong relationship, another one is a weak relationship. Strong relationship is represented with a single diamond and weak relationship is represented with double diamonds. How one entity is connected with another entity? With the help of relationship. Now, when we talk about entities, we have various attributes. There are multiple types of attributes. Each type is represented differently, which we have elaborately seen in the previous lectures. Single attribute, composite attribute, multi-valued attribute, derived attribute, and null attribute. Each has their own way of representation. Now, this is about the basic ER features. Before stepping into the extended ER features, let's test our knowledge with the basic functionalities. Let's test the basic structure and components in the ER model. I'll project the name of the symbol. Please recognize for what purpose that symbol is used in ER diagram or in the ER model. The first one is rectangle. I hope you are done. When we talk about rectangle, basically rectangles are used for representing the entities. Let's move on to the second one, diamonds. Think about for what purpose diamonds are used. I hope you are done. Diamonds are used for representing the relationship. What about undivided rectangles? Undivided rectangles are for representing strong entity sets. What about lines? Lines have various purposes in ER diagram. It is used to link an entity with a relationship or an entity with an attribute or an entity to a relationship. Let's see the next one. Dashed lines. When we have optional relationship, then we can go for dashed lines. What about the next one? Double lines. Double lines are for total participation. We have 2 types of participation constraints, partial participation and total participation. So double lines are used for total participation. The last one is double diamonds. Double diamonds are for weak relationship. So this is about the basic ER features. Now you may be wondering why we are dealing with this. Because these are the symbols that are used as the basic structure and components in the ER model. But in this presentation, what we are focusing on is the extended ER features. At first, we need to understand why do we need extended ER features. When we talk about databases can be of any size. It can be a smaller database or it can be a larger database. Designing databases for larger enterprises, say for example, an hospital management system or for a banking enterprise or for a software company, a lot of complexity is involved while designing. Obviously, ER diagrams comes in the design phase. When we are in the design phase, we may encounter a lot of complexities, that too when we are dealing with larger databases. So representing all these complexities in an ER diagram is really difficult. And that is why there is always a need to minimize the complexity. It doesn't mean that we are not going to work on the complexity. The thing is, we need to minimize the complexity in the ER diagram, because this ER diagram is actually going to be implemented in the next phase, and these designs are going to be implemented with the real softwares. So in that case, we need to minimize the complexity in the design phase itself, and that's why extended or enhanced ER features were added. So extended ER features, in other words, enhanced ER features were added to minimize the complexity of the databases represented in the ER diagram, and that too when it is for a larger databases. I hope now you are able to understand why do we need extended ER features. Now let's see what are the various extended ER features. In other words, enhanced ER features. We are going to focus on the first one, the specialization. The second extended ER feature is the generalization. The third extended ER feature is the aggregation. In addition to this, I will also throw some light on inheritance and more design options. Now let's focus our attention towards the specialization extended ER feature. When we talk about the extended ER features, the first extended ER feature that we are going to address now is the specialization. What is this specialization? It means when we have an entity or an entity set that may include subgrouping of entities in some way. It means an entity can be broken into some subset. If you think this entity is a superset, you can break this superset into smaller units called as the subsets, or you can break this entity into some subgroups in some way. For now, just understand, specialization means the entity set may be broken into smaller units, which is called as subtypes or subgroups. I know things will be unclear at this stage. Let me give you an example. It will be easy for you to understand. For example, if you consider the entity set as the person, the entity set is broken into smaller pieces or smaller units called subtypes or subgroups. So this person may be further classified as employee or student. So the logic is the entity or the superset person is divided or broken into two types or subtypes, employee or student. I'll give you another example. If you take artist, an artist can be a band or a musician. So basically, artist is the superset or the entity which is broken into subtypes, band and musician. Alright, why do we want to do like this? Because there may be a situation where the employee is described by some set of attributes that are different from student. You can see in the above example, the person entity is divided into two subtypes, employee and student. Though a student is a person, though an employee is a person, however, there may be requirements that this employee should be described by a set of attributes that are different from student. As you know, both employee and student will be having the behavior of a person. However, employee and student may be at times need to be described differently or with a set of different attributes. In database terminologies, if you consider these as entities or sub-entities, then obviously this will be described by set of attributes. So we want to describe the set of attributes for employee. That is what this is saying. Employee is described by some set of attributes that are different from student, which is this. So in this situation, specialization will be helpful to achieve this. I hope things are clear to you now. So this process of subgrouping within an entity set is called as specialization. So the higher level entity person is divided into employee and student. We are going to describe employee separately and student separately with different attributes because that's our requirement. In that case, the process of grouping this employee and student separately is called as specialization. Now a question to you. What kind of approach it is? Is it a top-down approach or a bottom-up approach? I request you to pause this video for a while and think about it. I hope you are done. And the answer is it follows a top-down approach because the higher level entity, which is the person, is divided into two subtypes or sub-entities like employee and student. So, higher level is divided into or classified into subtypes employee and student. So, this is following a top-down approach. And that is why it is a top-down approach in which a higher level entity is classified into subtypes that has different attributes. Anyway, when we see some examples, it will be easy for you to understand. For now, just understand it follows a top-down approach. I mean, specialization follows a top-down approach. And one more important point to note about specialization is that it is basically disjoint in nature. Basically, disjoint is the fundamental requirement of a specialization extended ER feature. And that's why I have mentioned the term basically disjoint. What do we mean by disjoint? I'll give you an example, then it will be easy for you to understand. When we talk about the entity, person has subtypes or sub-entities. So this person should be an employee or a student. I mean, definitely a person should be an employee or a person should be a student. There cannot be a situation where a person is neither employee nor student. And that is why this is referred as disjoint in nature. So definitely a person should be either an employee or a student. I hope this disjoint feature is clear for you. What about the relationship? Basically, specialization is a relationship. Example, person is an employee. Person is a student. So the relationship that is formed using specialization is a relationship. If you want to take the previous example, a band is an artist, a musician is an artist. Basically, artist is the higher level entity and the sub-entities are band and musician. Let's now see an example for specialization, then it will be easy for you to understand. We know the higher level entity is person. The person entity is described by attributes such as person ID, name, and address. And this person entity is the higher level entity. This can be broken into sub-entities like employee and student. Now, when we talk about employee, when we talk about student, basically a student is also a person, an employee is also a person. However, employee will also have ID, name, and address. Student will also have ID, name, and address. But there is a requirement that employee should be described by a different set of attributes. Employee needs a special attribute called salary, whereas a student needs another special attribute called total credits, where this is different from this and this is different from this. And that is why specialization is coming into picture. The higher level entity is broken into sub-entities, which is described by their set of own attributes as per the requirement. Now let's break this employee into two subtypes, which is instructor here, which is secretary here. An instructor is also an employee. A secretary is also an employee. However, instructor has a rank attribute. Secretary has how many hours he or she worked per week. So this is what specialization extended ER feature is about. As I mentioned, this is a top-down approach. So higher entity is subdivided into lower level entities. We are done with the first extended ER feature, the specialization. With this knowledge, let's step into the second extended ER feature, which is the generalization. What is this generalization? In the previous example, we have seen higher level entity is broken into subtypes, whereas here in the generalization, we are focusing on the lower level entities, where two or more lower level entities combine to form a higher level entity if they have common attributes. Don't worry about this. When we see an example, it will be easy for you to understand. Now, when we talk about generalization, we know that two or more lower level entities combine to form a higher level entity if they have some common attributes. This is more like subclass and superclass system in inheritance, but the difference is the approach. What is that approach? In the previous case, the specialization is a top-down approach, whereas generalization is a bottom-up approach because it is from the bottom to the up, where the lower level entities, two or more lower level entities combine to form a higher level entity. I'll give you an example. Let's say the entity set instructor has the attributes instructor ID, instructor name, instructor salary, and rank. These are the four attributes of instructor entity. And these four attributes can be generalized with another entity employee with the attributes employee ID, employee name, employee salary, and hours per week. What I mean to say here is, just see, an instructor is also a person, an employee is also a person. If you consider person as the higher level entity or the superclass, let's assume the subclasses are instructor and employee. Now what we are doing here is, we are grouping things between the sub-level entities or the lower level entities. So we are trying to group instructor and employee, which has features such as instructor ID, instructor name, instructor salary, rank in the instructor entity, with the employee entity, which is having the attributes employee ID, employee name, employee salary, and hours per week. So somehow we are finding the commonality and we are trying to group it so that more lower level entities can combine to form a higher level entity in a generalized way. This is what we call as generalization. So we are trying to generalize lower level entities with the common features or common attributes so that it can form a higher level entity. I hope things are clear to you. So this way of finding commonality or the commonality can be expressed by generalization. I hope things are clear to you. Let's see an example now. Let's take the same example, the person, which has ID, name, and address. So this has lower level entities, employee and student. When we talk about employee, instructor and secretary are the sub-entities for this employee, where employee is already a sub-entity for person. Now what we are doing is, we are just focusing here. In the example, what I was explaining is this portion. So we are trying to match some commonality in the lower level entities like instructor and secretary so that we can form the higher level entity. This is a bottom-up approach where the commonalities in the lower level is used to form the higher level entity. This is what we call as generalization. We are done with the second extended ER feature, the generalization. Now let's move on to the third extended ER feature, aggregation. What do we mean by this? When we talk about ER diagrams, the problem or the limitation with the ER diagram is it cannot express relationship among relationship. I mean to say, one limitation with the ER model is that this ER model cannot express relationship among relationship. We know relationships are used to connect two or more entities, but the problem is how a relationship with another relationship can be expressed. For example, when we talk about a ternary relationship between an instructor, a student, and a project. When we talk about binary relationship between instructor and student, we can have advisors relationship. But when we want three entities to have a relationship, like the relationship between instructor, student, and project, this we call as a ternary relationship. Already there is a relationship and we want to establish a relationship among relationship. But our requirement is to express a ternary relationship like this. In this case, we need to go for extended ER feature, which is called as aggregation. So how to deal with this? So when we have already a relationship, that relationship should be considered as a single entity so that a new relationship can be used to express that. It becomes the aggregation. I mean to say, the relation between two entities is treated as a single entity. Let's say for an example, instructor and student has some relationship. And this relationship should be treated as a single entity so that this entity can be linked or related with another entity project. So this is the idea behind aggregation. I hope things are clear to you. No worries, when we see an example, it will be easy for you to understand. So the relationship with its corresponding entities can be grouped into a single higher level entity. That's what I was telling you. There are three entities, instructor, student, and project. First, let's group instructor and student with some relationship. Then, let's consider this as a single entity and let this single higher level entity be linked or related with another entity project. So this is what this point says. The relationship with its corresponding entities can be grouped into a single higher level entity. So when we want to have a ternary kind of relationship, then the best way to model such situation is the use of aggregation. So ideally what happens? This single higher level entity is actually abstracting one level of relationship, right? It's hiding the complexity. So it is basically an abstraction. It is an abstraction through which relationships are treated as higher level entities because the relationship between instructor and student is going to be viewed as a single entity by this entity using a new relationship. So this portion is actually abstracted. That is what this point says. It is an abstraction through which relationships are treated as higher level entities. Let's see an example. Let's bring in the entities. We have instructor entity, we have student entity, we have a relationship between this instructor and student entity, which is the project guide. I mean to say, we have already seen advice's relationship is here. But what I am specifically focusing here is related to a project supervision. Let's bring in the project entity where instructor, student, and a project is linked. I mean to say, a student is going to do a project under the supervision of an instructor, and this project details are stored in this project entity. The basic student information, the project related information, the instructor related information. However, this instructor is going to guide the student, or this student is going to be under the guidance of this instructor in order to do the project. Now, the relationship is a ternary relationship. Can you see here? This is a ternary relationship. This is a situation where we have three entities, right? In this case, let's bring in an evaluation criteria as an entity. How this project is going to be evaluated is based on this complete performance of all these three entities. So, the inputs of all three entities are to be evaluated so as to evaluate this evaluation process of the project. Now, the whole thing, can you see here? Instructor, project, and student. This whole information is going to be working as a single higher level entity so that this whole information is abstracted, and this is considered as a single higher level entity so that this can be related with the single unit. This is the complete single unit. You see, this complete single unit is abstracted, and this whole unit is treated as a single entity or a higher level entity so that that can be linked with this relationship with evaluation. This is about aggregation. We are done with the extended ER features, the specialization, generalization, and aggregation. Before we sign out, I wanted to throw some light about inheritance. Basically, inheritance is a concept of object-oriented programming, or I would say it is a feature of object-oriented programming, where the higher level and lower level entity sets also may be designated by the terms superclass and subclass respectively. We can call as the parent class or the child class or superclass or the subclass. How this inheritance is related to this extended ER features. When we talk about person entity, we know it is the superclass or the higher level entity where it has employee and student as the lower level entities or the subclasses. So the crucial property of higher level and lower level entities created by the extended ER features specialization and generalization, we refer this as attribute inheritance. Remember, attribute is the term we use in ER terminology. I mean ER model or ER diagram terminology. So, the property what we achieve through this higher level and lower level entities created by specialization and generalization, we refer that as attribute inheritance. Basically, inheritance is a feature of object-oriented programming, and we refer here differently as attribute inheritance in extended ER features. So, the attributes of a higher level entities are said to be inherited by the lower level entities. I mean, in general, the properties of superclass will be inherited by the subclasses. Likewise, the attributes of the higher level entities are said to be inherited by the lower level entities. For example, the attributes of employee and student subclasses inherit the features or properties of person entity set. So, student and employee inherit the attributes of person. And that's it, guys. Before we sign out, understand the importance of having the extended ER features because they are crucial in the design world. When we talk about design options, when you see object-oriented analysis and design, which are very, very important in the software industry field, when we talk about object-oriented concepts, there are a lot of design options. I'm not going into the details of this. However, I want to throw some light on this. When we talk about more design options, we have class diagrams, we have object diagrams, use case diagram, sequence diagram, collaboration diagram, state diagram, activity diagram, component diagram, deployment diagram, package diagram, interaction diagram, timing diagram, composite structure diagram, UML diagram, the unified modeling language diagram, where this UML diagram even contains interaction sequence, collaboration, state chart diagrams, activity diagrams, implementation diagrams, and many more. Why am I telling all this? because extended ER features and ER diagrams gives you a strong understanding about the various design options used in the object-oriented programming world. That too when we deal with object-oriented analysis and design. We had a very elaborate lecture today. I hope the session is informative and thank you for watching.